sort of important. I do need to talk to everybody about tomorrow. Tomorrow we will not be having an online session. Okay, this is very, very important. I don't want anyone to waste their time waiting for me. Tomorrow you will not be having an online session. I need everybody to tomorrow or later this evening when I post it. You guys all know I post my announcements for the day a little bit early in the afternoon. I try to get them up by 4 o'clock. I was a little late yesterday because there were other things going on that I had to be involved with. But I try to get my announcements up for you way in advance. Please, 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 and I can't say this enough, look for my announcement for tomorrow and follow the directions of the announcement. You're going to have a few videos I want you to watch, nothing crazy, and you're going to have an assignment to do again, and I'm going to give you time to get your homework done. Okay, let me tell you why I'm having to do this. Okay, it's not me being lazy. It's not me wanting to spend an hour and a half with you because I actually enjoy these course times for some odd reason. But it's more that I have to be involved in a planning session. We're starting to plan for how to bring you guys back onto campus, at least 10 smaller groups for shop and stuff like that. My job responsibilities is not just HVAC. I'm responsible for a few other programs as well, and I have to be involved in this planning session. So that's why there's going to be no online conference tomorrow. Again, it's not me being lazy. It's just I have to be involved in this other session. So, again, I will say this again near the end of the lesson, but it's very, very important. Don't come online waiting for an online conference tomorrow because it's not going to happen. Look for my announcements. There will be an assignment, and we just need to be aware of that. The other thing that I want to point out is today's assignment of the day is not a discussion board. Okay, I put an assignment out there. It's called assignment question, well, for 420. That should have said 429. But it's basically sequence of operation of forced air furnace. I want you guys to give it to me in your own words. Okay, I am the only one seeing it, so be as direct and as in detail as you can possibly be. Okay, the only wrong answer is the one where you haven't made an effort. Okay, spend more than 30 seconds answering this question. I need to start seeing that there's an understanding of some of the stuff we talked about in lecture. Final housekeeping issue before we go on with the material is some of you I have sent individual emails to. Okay, if you get an individual email from me asking you a question or letting you know that I'm missing a few assignments, please take the time to reply to me. These emails that I send are not automatic, and it's really, I send them out because I sort of give a crap, and I don't want you to end up at the end of the course and not have things turned in. So that's why I'm sending it. I'm giving you an opportunity to respond and get that stuff to me. Okay, if it's late, will you lose a few points? Yeah, you will. But I'd rather have a late assignment than no assignment at all. I don't know if that makes sense, but I don't like seeing zeros, and I don't like seeing missing work. So I want you to turn this stuff in. Okay, now 10 days late, you're not going to get much of a grade, but if it's 2 or 3 days late, you're not losing that much points, and you're still getting the assignment, and that's the most important thing for me. So any questions on anything that I just asked you or I just went over? Okay, tomorrow's lesson will be more of a follow the direction type lesson, and then the stuff on the assignment. Any questions?
Negative. You could go first.
Go ahead. Whoever was going to ask a question. I heard a negative, but I heard someone asking a question.
Oh yeah, so what I was going to say was the other day I didn't do the discussion for the 28th, so is it possible that I can still do that?
Discussions I don't normally open back up, but if you want to send me your answer to the discussion, I'll take that into account. Of course, you'll lose a few points, but I'll do something with it.
All right, yeah, cool, thanks.
Okay, again, I'd rather have an assignment turned in than not turned in.
Like me also, man, I felt like behind a lot because of my setup and all that stuff. And I think I made you aware, and the other people. Leia and the director at the Waterbury campus.
Okay, if you have a specific thing you want to turn in and want me to look at, email it to me. Okay, I'm not going to in the call go over the personal, individual stuff. Okay, but email it to me.
Right.
Okay.
Okay. Yep.
I do need to maintain a little bit of student privacy, especially since I record these. That's why I don't want to go individually. Okay. So again, my biggest thing is, please, tomorrow, do not come online waiting for an online session. It's not going to happen. But you will have work to do. It's not a vacation day either. I won't bury you, but I do have to have some material done. So today what I want to talk about is I really want to talk about control circuit wiring for the oil-fired equipment. And I also want to talk a little bit about the fan limit switches. Okay, I started talking about both of this stuff yesterday when we were going through schematics, but it's sort of important that we go through the actual presentations and we talk about individual components. Okay, so the first thing we do on any control circuit, and again, I'm talking operating and safety controls. The first thing we look at in any control circuit, and this is not just oil, is I look at what the function of the equipment should be. Okay, what are we doing with the equipment? What's our end goal? That's the first thing we're looking at. Okay, so in this example, I'm looking at an oil-fired forced air furnace that has a low voltage thermostat, has air delivery temperature controls. In other words, we want to know what the temperature of the air going into the space, has burner ignition controls as a safety feature. So just looking at this slide, without going to the next slide in your handouts, which I'm sure some of you are about to do, with just looking at this slide, what is the minimum equipment I have to have? Anybody? It's okay to be wrong. Minimum equipment I have to have.
Thermostat.
Have to have a thermostat.
Fan limit.
Okay, have to have a fan limit. That's my air
Motors.
delivery temperature control. Keep going.
Fan center.
Do I need to have a fan center? You know, let's put that off to the side as a question mark because you're missing one piece of information. So I'd say a possible on fan center, okay?
What about 24-volt control board?
Control board, or what else gives me my 24 volts?
Transformer step down.
I have to have my transformer. Okay, what else do I need to have?
Contactor relay.
For what?
For your motor.
For my, well, possibly. I would put that under my possible because somebody already did say the fan limit. That's going to take care of the fan motor. We haven't talked quite about that yet, but go on. What else did someone say?
Motor.
I have a fan limit. Someone already said that. That's my air delivery. What else do I need to have? Think about the burner. What's going to create my spark?
The electrodes.
Okay, but yeah, so electrodes. Okay, you said transformer here for my low voltage.
The ignition, right? Transformer.
Yeah, I have a step-up transformer, right? Okay, so all of this needs to come. I don't know who that is, but yeah, I do know who that is. Just fix that. Okay. Burner, we all have to think about all of these parts we've already started to talk about. We have a burner motor. We have the ignition control on the burner, which we're going to talk about probably on Monday. We have the transformer. We have the low voltage transformer. I have a thermostat. I have a fan limit. I have a blower motor. I heard a lot of those as we were going through this. Okay, so all of that comes into play. Hey guys, I'm going to mute everybody. If you have a question or anything, please unmute yourself and ask the question. Okay, so let's talk about the electrical components. Okay, again, our standard home electrical source is, the book and everything will say 115 because it's a little bit old, but the reality is most of our voltages now are 120. Okay, so 115, 120, it's still standard household electrical code. I have to have a fuse or a breaker. Every circuit I have has to be controlled by a fuse or breaker. It's a protection device. It makes sure that we have proper amperages, we don't have a short, and we're not going to burn the building down. So we have to have the electrical components. Our source, a fuse or breaker, and we have to have an internally protected, which basically means it has an internal motor protection device, and it's a fan motor. We have to drive the forced air fan. We have to push the air around the house. This is known as our blower motor as well. Okay, forced air fan motor. PSC, we talked about it yesterday, has a capacitor inside of it. We have to have a normally open temperature sensitive switch for temperature control. Okay, I drew one of these. We drew one of these in our diagrams yesterday. A normally open temperature sensitive switch for temperature control. Okay, this is basically the equivalent. Remember, I said we're going to use the same close on rise thermostat that we use. It's normally labeled a cooling thermostat, but the reality is it's close on rise. Okay, that as the temperature goes up, that's eventually going to close. We have a normally closed thermal switch again to prevent overheating. This is our high limit switch. So I'm going to have the normally closed high limit switch. That's going to open if the temperature gets too hot, and that's a closed switch. So as the temperature goes up, that's going to open if the temperature gets too hot. This is to prevent the furnace from overheating. We're going to talk a little bit more about this in the fan limit part of our conversation today. Any question on these three components? Because we've sort of talked about them already. Okay. We have to have a burner motor relay that's needed to control the motor that both pumps the oil and supplies the combustion air. We have to have a 14,000 to a 20,000 volt ignition transformer. We have to have electrodes to ignite the fuel oil. We have to have a CAD cell flame detector, which we're going to talk about as we go through the rest of this course, to ensure flame. Okay, we want to shut down the motor. We want to shut down the oil feed if the flame goes out. Okay, real quick, I don't want to get into too much information on this without talking about the whole control system. This device right here senses light. It's a CAD cell flame detector. Senses light. It senses the flame. Okay? If the flame goes out, the CAD cell detector no longer senses light. It shuts down the burner motor. And therefore, it's no longer dumping fuel oil into the combustion chamber. It's a safety device. No flame, no light, no burner motor. Any questions on that?
Nope.
Okay. CAD cells don't last forever. They're a primary source of failure if they start getting soot or smoke onto them. That's why having such a clean flame and a clean burning flame is important. The electrodes contribute a lot to the clean flame. An oil burner primary control is needed to supply the low voltage for your thermostat and the line voltage for ignition control. A thermostat with 2 terminals is required for automatic control. 2 terminals for heating, R and W. Okay, heating thermostat. The schematic symbol is this, with straight lines. I can't draw straight lines with my mouse. Okay, but basically it's this. This is a heating thermostat. I'm sorry, heating thermostat. Other way. My fault. You erase that and do it right this time. Just came out of an air conditioning class. Okay, we have 2 thermostat terminals required. Heating thermostat. Closes on temperature drop. Okay, temperature drops, this closes. Okay, allows a continuity from R to W. Is a thermostat a switch?
Yes.
So am I going to have any resistance when this is closed?
You should.
Why?
That I couldn't tell you.
Oh, come on. What did we talk about yesterday that's in series with the thermostat?
The relay coil.
There's one small device. I said it's adjustable in a, or we might have talked about it when we talked about thermostats. I said it's adjustable in a heating thermostat.
High limit.
Nah, that's not going to be with your thermostat. Anybody remember the anticipator?
Ooh, no.
The heating anticipator provides additional heat to the thermostat to prevent overshoot and lag. Okay, it's a little resistor that is actually, if I drew my thermostat, my internal components of my thermostat out, okay, I have this, and then in series with that thermostat, I have a little resistor that's adjustable. Okay, this resistor is set to the same amperage of my primary control. Okay, like 0.2 amps. I mean, this is very small amperage. What this anticipator does, it actually provides some heat to the thermostat, so the thermostat thinks it's a little bit warmer than it actually is. When you shut off an oil furnace, is the furnace still hot?
Yes.
Yeah, so the furnace is still going to be hot. What happens if I leave hot metal to cool on its own? What's going to happen to the weld joints in the center in that furnace if I leave hot metal to cool on its own?
They're going to crack?
They're going to crack because the metal's cooling at an uneven rate. So what we want to do is we want to let the fan motor continue to distribute heat a little bit after the burner shuts off. We want to cool the furnace by using our blower motor, and we want to pump that heat into the house. If I did not have this heating anticipator, and my thermostat is set for 72 degrees, that's what the thermostat is set at. That's what the building owner wants or the homeowner wants. If I pump that residual heat into the house, my house may be shutting off at 75 degrees. Rather than 72 degrees, because of that additional heat that metal of that furnace is holding. So our heating anticipator actually creates a little bit of heat when this thermostat is calling for heat. Okay? And it puts a little bit of heat onto this sensing mechanism in that thermostat. And it says, okay, the thermostat now thinks it's 72 degrees, but it's actually 70, so that residual heat I'm going to blow out of the furnace is going to warm my house that extra 2 degrees to get it to 72 degrees. Okay? It is one of the few control devices that we put in series. Remember I said it like 90% of the time, 99% of the time, we don't have anything, we don't have 2 loads in series. But that heating anticipator is one of the few control devices I might put in series with another device. It's built into the thermostat. It is not in digital thermostats. Okay, it is only in the old Mercury thermostats. By the way, when I put a dotted line around something, it means it's one device. Okay, you 9 out of 10 times do not even need to think about this being there, but it is there. So if I take a resistance from the R to the W terminal of a thermostat that has a heating anticipator, I'm going to get a tiny bit of resistance. If I take a resistance across a thermostat that does not have a heating anticipator, okay, I won't get resistance. Make sense?
Absolutely.
Okay. So let's walk through this by itself. The 115 volt line voltage has to be supplied to the plenum switch, the thermal limit switch, and the oil burner primary control. This is my power in. We put it to 3 places. I put it to the thermal limit switch, I put it to the oil burner, and I put it to the primary control. 3 places my line voltage goes in a basic circuit. Okay, we're going to show you a diagram of this. As a matter of fact, I think you've already seen one. I drew one out yesterday. When the thermostat closes on temperature fall, a circuit is established between R and W on the thermostat and between T and T on the primary control. This component we have not talked about yet. Okay, primary control, we're going to start talking about that Monday. So T and T is 2 terminals on the primary control. All R and W does is close a circuit between 2 terminals on the primary control. The circuit is completed through the low voltage side of the primary control, and it actually energizes the burner motor. Okay, it basically, as long as all the safeties are closed, it turns on the burner motor. Okay, it also turns on the ignition transformer. Okay, as long as my high limit switch is closed. And again, we still have to talk about the primary control. But the primary control is what energizes the burner motor and the limit switch. Let's see if I can show you this. This is tough to show sometimes. Okay, I'm holding my hand a primary control for anyone who wants to see what one looks like. Okay, it's a little device. It's not that wide. Okay, this is one of the newer styles. It's digital in nature. On the back of it, you have color-coded wires. There's a black and a white. This one has a purple and an orange. There's also a blue and a sort of a blue and a white lined one together. Anyone want to guess what black and white goes to?
Your power and neutral?
Line and neutral. Orange always goes to my burner motor.
Yeah, burner.
Purple. Okay, purple and blue are not always there. Okay, in this transformer, my white and blue combination goes to my ignition control. Purple goes to an oil valve solenoid. Again, it's not always there. At a minimum, every oil burner control you have is going to have your white, your black, and your orange. Sometimes all of your components, your ignition control, your burner motor, and if it's there, the solenoid is going to be attached to the orange. As the controls get more complicated, they start adding additional wires. Okay, we also have, I mentioned a CAD cell. CAD cell will always be orange wire, okay, and I know it's tough to see, but on the end of this black piece in my hand, you have sort of a lens with wiring in it. That lens with wiring in it actually collects light. The resistance of this whole thing changes with the amount of light that's in that CAD cell. Okay? As the CAD cell goes dark, there's less light or less resistance. As the CAD cell gets light, there's a lot of resistance. Can I use the CAD cell as a bypass over a device?
I don't think so.
Is the CAD cell sort of acting as a switch?
Actually, yeah.
Yep.
So can I use the CAD cell as a bypass around a device like a little heater?
I guess you can.
Yeah, we're going to talk much more about this, but that's what the CAD cell does. It acts as a bypass. Okay, we use a little heater in our primary control to pop a safety switch. Okay, it's like a 90-second delay, if that. Most are now running 30 seconds. If the CAD cell doesn't see light, we pop the safety switch, and the motor stops, and we stop dumping unburned fuel into the combustion chamber. Okay, again, we're going to spend a lot more time on that, but I just wanted to sort of show you as best as I can what the parts are. Okay? And you should have seen the look on the supply shop's face when I walked into the supply shop in Tampa and asked for an oil burner control. The ignition transformer creates 14,000 to 20,000 volts between the two electrodes to ignite the oil being pumped in. The ignition transformer is a step-up or step-down transformer.
Step up.
It's a step-up transformer. The oil is ignited. The CAD cell flame detector that I just showed you, the yellow thing, will detect the flame and complete a low-voltage circuit through the flame relay coil. Okay? When energized, the flame relay coil will open the flame relay contacts and turns off what we call a safety switch heater, and I'm going to spend more time on this when we talk about the internal workings of the safeties. But it basically turns off a safety switch heater by bypassing it. If the oil fails to ignite or if the flame goes out, the flame relay contacts stay closed and the safety switch heater remains in the circuit. After several seconds, the heater will start warping. Okay, it's bimetal. The safety switch is bimetal, and it interrupts the circuit to the blower motor relay, opens all of the controls, shuts everything down. Who can tell me what bimetal is? Give me a basic definition of what bimetal is.
It's two different types of metals that have different, different heat temperatures will make them warp.
Yeah, they expand and contract at different rates. So if I put these two different pieces of metal, two different types of metal together, if I sort of sandwich them together, they're going to bend as they heat and cool. Okay, you got it, yeah. And by doing that, I can actually open and close contacts. I can pop a safety switch. Okay, and I can turn everything off. The oil burner primary control will not recycle until the safety switch heater has cooled and the safety switch is closed by pressing a manual reset button. Okay, now this is extremely important. Every time someone presses a manual reset on an oil burner control, like the one I just showed you, it has a manual reset button on it. Every single time someone presses the manual reset, the burner starts. The ignition transformer starts. If there's a solenoid, that solenoid opens and allows fuel from the oil tank to be sprayed into the combustion chamber. If the flame does not ignite, that fuel is still in the combustion chamber, puddling at the bottom of it. What happens when the oil burner tech comes along and eventually fixes the problem after the customer has pressed that safety 20 or 30 times?
I assume there's a large cleanup for him.
Well, if he notices there's a relatively large oil cleanup, if he doesn't notice and ignites that burner, there's a relatively large bang, and there's a lot of smoke and soot cleanup that happens, including usually a company that comes in and does the cleanup of the whole house, including repainting. Okay, So the rule of thumb, and we're going to talk about more of this when we start talking about the primary control, when I have gone to an oil call in the past where someone does not have heat, the first thing I ask the homeowner is, how many times did you press the safety reset button? They're going to say, oh, I tried it a couple times. Because it's written on the box, don't try it more than 3 times. You as a technician, are you going to trust what the homeowner said?
No. Of course not.
Oh, hell no. Oh, hell no. Okay, no way. I'm going to pull that burner compartment open, and I'm going to check and make sure that there's not a lot of unburned fuel in there before I do anything else. Because the second I get a flame on that burner, even if I say, oh, I'll just check it and see if it runs, and I'll shut it off real quick and then check inside. Nope, too late. Once that oil catches, once those vapors catch, I have actually seen a boiler lift about 6 inches off the ground. A big, heavy steel boiler. Okay? So just be very, very careful here, because you can get seriously hurt here. So again, the safety switch says only press it 3 times. Okay? That homeowner is going to try to press that thing 10 or 20 times. Okay? They have a choice, paying your overtime or maybe getting the thing to ignite if they press it enough times. Now, the primary control that I just showed you, okay, will actually lock itself out, okay, if someone presses that more than 3 times. You can always look at the back of the primary control, the part the customer cannot see, and you can find out how many times it will allow the homeowner to reset it by just pressing a button. A lot of them now have a lockout. The newer ones that are digital have a lockout that will actually lock itself out if the homeowner presses the button too many times. Okay? You can reset it by turning it over and following the directions that are on the back of it. Now, having said that, do you ever tell the homeowner where to find those directions?
No.
No. Okay, there's some things that it's just worth making the late night service call on, and that's one of them. Okay, primary control is locked out. Sorry, homeowner can't reset it anymore. They think the primary control is broken. I never show the homeowner where the reset on the primary control is after it's locked out 3 times. Never. Can they find it on the internet if they go look hard enough?
Of course they can. You can find anything on the internet.
Yeah, just ask Dr. Google. Okay, so sequence of operation for an oil burner for a forced air furnace. We can have power to the furnace. Thermostat calls for heat. Closes R to W. Closes the TT on the primary control. Okay, energizes the burner motor. Energizes which turns the fuel pump, supplies oil to the furnace. As long as the CAD cell sees light, that flame continues. CAD cell doesn't see light anymore, the burner shuts off and pops the safety switch. CAD cell never sees light, it never starts up. Just as an odd thing here, if you have that CAD cell out in the room and you try to start the burner with the CAD cell seeing light, the burner's not going to start. In other words, if the burner compartment is open and that CAD cell is seeing light, it's not going to let the burner start. The CAD cell has to be in the dark before it lets the burner start. It's again a safety to make sure that somebody doesn't have the burner compartment open and tries to start that furnace. Okay,
so will that...
Go ahead.
I'm sorry, will that still work whether it's natural light or artificial?
Yes.
Okay.
Yeah, we used to, before we got in a little bit of trouble doing this, when I was actually teaching more often in the shops, one of the things I used to do is take an oil burner, take a 55-gallon drum, and I take that thing out to the back on a loading dock or a back parking lot, and we'd fire the oil burner right there on the back, in the back, so you guys could see the flame patterns. Okay, because it's really great to be able to just see the flame coming out of the oil burner. I could show you the air adjustments, fuel adjustments. I could show you what different flame patterns look like. We could show you what different nozzles do and everything else like that. One of the things we always had an issue with was that the CAD cell doesn't see light or sees light all the time. So you actually have to go through a sequence. Your shop instructor, when you get back on campus, is going to show you the sequence of how to fake the primary control out for testing purposes so that you can actually think it sees light or not see light. Okay, there's a way to do it. But the CAD cell is a pretty important safety device. Before the CAD cell, does anybody know how we were sensing whether or not there was flame?
Stick your hand in there.
The heat sensor?
Okay, I'm going to ignore the stick your hand in there because that just doesn't quite make sense from an automation purpose. But yeah, it was a heat sensor, and it was actually in the smoke pipe coming out of the furnace. It was called a stack relay. We're going to talk about them as well. We have to talk about them because they still appear on state licensing exams, but we need to realize that they're going away. Okay, so control circuits of oil systems are actually somewhat easy. There's not a lot to them. But one of the primary parts of the control system of an oil furnace is the limit switch. The high limit switch is a primary component of our safety devices. Fan limit switch. Who here, anybody on this call, have had gas heating already?
Yes. Yep.
Okay, so some of you have already seen this switch, okay? I may describe it in a different way than your other instructor did. Forgive me if I do. Okay, there's different ways to describe this. Okay, but this is a fan limit switch. This device is actually mounted usually on the front. Oops, let me turn my pen on. Okay, this device is usually mounted on the front of the oil furnace, and you also see these in gas furnaces as well. Okay, the portion here, it's called a helix, sticks into the plenum. By plenum, I mean the area where the room air is circulated through, not into the combustion air, which is where the flame is, but it sticks into the area of the furnace where room air is circulated through, and it heats up. As this helix area heats up, it will start turning this dial. Okay, because again, this helix is bimetal. And when you have a helix of bimetal, it can create rotation as it heats and cools. This dial has four settings, or 3 settings on it. Okay? And I'm going to talk more about those 3 settings. It hits a set of contacts that is mounted in this plastic, and it opens and closes switches based on the mechanical motion in this dial. These are slowly going away. Okay, if I had to guess, in 15 years, you will not find these fan limit switches on any piece of equipment that's being sold. But right now, these are still extremely in use. Okay, we're going away and we're going to more digital controls. But right now, you are going to see these on the majority of oil forced air equipment. Again, on oil forced air equipment, you see a ton of these. On gas equipment, you're starting to see less and less of these. Okay, they're starting to go away. Okay, so what the fan limit switch does, it does 2 things. It controls the fan, which is the blower that blows air around a room, and it acts as also a high limit switch. Okay, the fan limit switch turns on the fan at a pre-temperature, and it turns off the fan at a preset temperature. The whole purpose is, A, we don't want to blow cold air around the house, and B, we want to make sure the furnace cools off when it's done. All of that is handled by this limit switch on the fan side. On the high limit side, okay, we have another important issue. It's a safety. Okay, we don't want to circulate cold air through the ductwork. Okay, the fan limit switch is heat sensing. When the furnace overheats, this element will open a set of contacts shutting off power to the burner or the ignition source. We want to shut everything down. Different state codes have a different high limit cutout requirement. It's usually set to between 200 and 250 degrees. I don't think I'm dealing with any state on this call that has that high limit requirement much over 200 degrees. Okay, most of them don't allow up to 250 anymore. Your furnace manufacturer will tell you what the high limit setting is. Don't go over what the furnace manufacturer has this set for. A lot of times they come preset with a screw in there so you can't move it. The fan limit switch can be high voltage, it can be low voltage, or it can be a combination of high and low voltage. Remember what I showed you yesterday on the schematics, that there's different ways to wire these things. It can be all be on your high voltage side, it can be on your low voltage side, or it can be a combination of high and low voltage. I personally like to see it on the low voltage side, but I'm seeing a lot of them coming from the factories as a combination right now of the high and low voltage. Again, because of the digital thermostats. High voltage only, those are getting older and older. We don't do that often anymore. There's too many problems there. The fan and high limit contacts are controlled by a helical bimetal position next to the heat exchanger. That should say next to the heat exchanger. The combination control can be easily retrofitted for the different voltages in the field. Okay, it's very easy to change the voltage requirements. You just cut a little metal tab inside of it. This diagram over here shows someone with a pair of pliers breaking the metal tab. If I break the metal tab, I can have one side high voltage, one side low voltage, or two different circuits. Okay? If the furnace calls for both high limit and fan controls on the high voltage side, we leave the jumper tab in place. If we remove the jumper tab, I now can be using two different voltages or two different circuits. Be very aware of this when you have to replace a fan limit switch. Okay, when they come from the supply shop set up for high voltage, the jumper tab will be in place. To go to a low voltage, you have to pull the jumper tab out. You have to remove it. If the furnace calls for a high voltage fan control and a low voltage limit control, the jumper must be removed to separate the two voltages. This is a very frequent setup. The fan control is on high voltage. Okay, line voltage coming into the fan. The low voltage side is your limit because that's where the burner controls are. Okay, that's where our primary control setup is. Okay, so we have the low voltage side having my high limit, high voltage side having the fan control, the blower control. We have to remove that jumper. I have seen people blow up primary controls because they forget to remove the jumper. Don't be Dave. Okay, I mean, don't forget to remove that jumper. The switch also has a delay in shutting the blower down. That's on the fan limit side. It allows the heat exchanger to cool. Again, I don't want to let the heat exchanger just cool on its own. It's going to cool at different rates. Different parts of it are going to cool faster. We want to dissipate the furnace heat at the end of the heating cycle and get it into the space. The temperature sensing element of the switch, called the bimetal helix, is located in the airstream near the heat exchanger. When the furnace turns on and the air is heated, the bimetal expands and it closes the contacts, turning on the fan. Again, if I have a coil of bimetal or a helix of bimetal it can actually generate motion. It can generate the motion in a circular pattern. Bimetal helix, as I pointed out earlier, is the part that goes into the heat exchanger. Your controls are mounted on the outside of the heat exchanger. The fan limit side, the limit side of this device is a safety device. If the fan does not come on, or if there's another problem causing the heat exchanger to overheat, the limit switch will open its contacts, shuts power down to, well, this was gas valve, but it's the oil burner. Shuts my ignition off. Okay? Shuts off all my flame. We use the same control on gas. That's why it said gas valve there. But the oil burner turns the system off. Okay? Blower motors fail occasionally. People do stupid things like blocking air vents. If that furnace overheats, I have to shut it down. If I don't shut it down, the fire department's going to be there. You don't want to deal with the fire department because the control was either bypassed or blocked. Okay, we got to have these limit controls in the system. Okay, when you look at this is a wiring diagram. Okay, this is a wiring diagram. This is not a ladder schematic. Okay, when you look at a wiring diagram, you'll be able to see where you bring your hot and neutral into. Okay, we'll bring my line into my fan limit switch. One side of it controls the fan motor. The other side of it goes to my primary control. My black, my white, and my orange. Okay. Where's my transformer for my thermostat? Where's my transformer? Anybody? It's okay to be wrong.
Ignition transformer down at the bottom.
No, that's my ignition transformer. Where's my transformer for my low voltage thermostat?
I'm not seeing it anywhere.
Believe it or not, it's in that primary control. Okay, this primary control contains my transformer. There's the TT terminals that I said. This is R and W on the thermostat. So when my thermostat calls for heat, I close R to W, and effectively I'm putting a wire across TNT. Okay, and that starts my whole heating cycle. CAD cell, okay, connects to the primary control. There's two terminals marked F and F. That's where my CAD cell connects. I don't know what F stands for, but that's where my CAD cell connects. It's always yellow wire, too. Okay? Primary control contains everything, all the relays, everything I need to make the burner motor run, the ignition transformer work, and all the cycling is in that primary control. So, is this fan limit switch all 120 volts, or is it a split between 120 and 24?
All 120?
Yeah,
all 120.
It's a dry switch, right?
Well, I don't want to say it's a dry contact, but it's all 120. Now, what happens if that limit switch opens and the customer has a digital thermostat without batteries?
Power, sir? Power go up?
Yeah, if that limit switch opens, I no longer have power to my transformer. So that display and any programming that's on that thermostat will get lost. This is exactly why I do not like limits on the line voltage side. Because it actually cuts the power out to everything on the control voltage side. Okay? Not the best idea in the world, especially with digital thermostats. Okay? So we're going to talk about more of the wiring on this. But any questions when you're looking at this?
No, sir.
Okay. There are several settings on the fan limit control. Okay, again, we have this one is set up, fan on. My furnace starts heating up. The first setting that it's going to go to is my fan on. Don't get confused and think about what my fan off is. My first setting that this is going to actually do anything with is fan on. This one, fan on, is set for 150. Okay? If the fan does not come on, or if I don't have enough airflow for the equipment, okay, the limit on this one is set for 200. If the limit of 200 is reached, it's going to turn the burner off. We get no more heat source. It will cool down. Okay? When it gets usually back down to roughly where the fan on is, it will turn that burner back on. So you can have a system that's not blowing air around the house, that's actually bouncing on and off on high limits. Okay. Let's say this is working properly. Fan comes on and the temperature of that furnace stays roughly around 150, 160, under 200. Okay? We blow the air in the house heats up. The thermostat opens. And the burner shuts off. Okay, I no longer have heat being provided, but this fan is still running. We're still blowing the warm air out of that furnace. That warm air is going to continue to blow until we cool down to the cut out point, the fan off point. Okay? And that's going to be, this one set for about 100 degrees. These are normal settings. These are the factory default settings. Okay, fan on, around 150 degrees. Fan off, around 100 degrees. High limit, 200 degrees. These settings tend to work pretty well. Okay, why do I want to turn the fan off at 100 degrees and not bring that temperature down lower?
Because it's going to keep rising.
It won't keep rising because there's no burner at this point. This is the off cycle. But someone else said something, so go ahead and say that again. I didn't hear it.
You always want the temperature to be higher than your body temperature.
Correct. I always want the temperature of the air I'm blowing out of the ductwork, unless it's air conditioning, to be hotter than my body temperature. I don't want the building occupants to feel cold drafts. Okay, so I turn it off at 100 degrees. Okay, so fan limit switches, again, relatively easy operation. See if I can get back to what I had open yesterday for you guys. Is this a combination low and high voltage limit switch that I had drawn for you guys yesterday?
Yeah.
Yeah. Okay. So is the tab pulled or is the tab in place?
The tab's pulled.
Tab's pulled. Okay. Now, if I wanted to change this around, okay, and put the limit side on my high voltage, and quite honestly, you do see this occasionally. Okay. Well, limit here is on my high voltage. It's on the burner. but I wanted to put my fan switch on the high voltage side. I could remove, and let's pull that. Let's pull that. Okay, I can put that whole piece. Of course, it's not going to draw properly. Let me just... I could put that whole piece right up there instead of the fan relay. Okay, so I can eliminate the whole fan relay portion of this. And I could put my limit switch, okay, up here. Or my fan switch, I could put that right there. Okay, and as the temperature of the ductwork warms up, I could pull my limits up. I can turn my blower motor on. Okay, and that should be a thermostat looking switch up there, and it's just not going to cooperate for me right now. Okay, so I could put my fan switch there, and then I don't need this down there at all. It all of a sudden makes my diagram, my low voltage side, easier. That's one way it's wired. Now, if my high limit opens on this wiring, do I lose my power to my thermostat?
No.
No. However, when these used to come wired from the factory, these were not put into place right here. Okay, they were put into... As I told you guys yesterday, there's about 6 different ways to wire these things. They were actually put into the wiring diagram down here. Okay, so they used to take out the entire low voltage side of my wiring. What happens to your thermostats?
Turns off.
Yeah. Okay. This becomes a problem. Because if I have a regular thermostat without a digital display or a digital thermostat with batteries, the homeowner will never notice. But if I have a digital display thermostat that relies on that transformer, and if it's wired this way, what is the homeowner going to see every time that limit switch opens?
It would kind of reset the thermostat.
It's going to reset the thermostat. Would that drive you nuts as a homeowner?
Yeah.
Yep.
Yeah. Oh, yeah. Okay. By the way, when you reset a digital thermostat, there's a delay before the heat comes back on. Okay, and a lot of times we do use the high limit switches, especially on boilers, as an operating control. So we try not to do this anymore. You still see this in books. This is why I want you to be aware of this whole problem. You still see this whole thing in some of the books you'll look at. Okay? But remember, a lot of the books you're reading, a lot of the books on oil burners, were actually written before we started having a lot of digital controls. Digital controls need a constant source of power. Okay? So when you look at oil burner controls, when you look at these controls, I want you to remember that if this thermostat is digital, you've got to keep power on that thermostat. Any questions on that? Does it make sense to you?
Yeah, it makes sense.
So far.
Okay. Primary controls, whole topic of different conversation. Okay, we're going to spend probably a day on primary controls. I don't want to go there yet. I know I'm holding out on everybody on that, but I got to get these basics down. Does anybody have any questions on any of the schematics we went over yesterday?
Still learning as I go.
Learning never ends. Learn something new every day. Okay? So the learning process continues. Learning is a good thing as you go. You're not going to know it all, so that I'm fine with that. But does anybody have any questions on anything I covered today or yesterday? Okay.
No, sir.
I know this was a little short today. I've only taken an hour of your time, which is about right for what we covered today. I just want to remind everybody, look for the course announcement for tomorrow. There will not be an online session tomorrow. I do have a list of things for you to do. You're going to have to watch a few videos. They're basically reviews of things we already covered. I'm giving you time to get your assignments done. I will have another schematic for you, nothing you haven't seen before. Okay? Nothing you haven't seen before. So if you are lost on the schematic, you can always go back and watch past couple days recorded lectures. And once you get your work done tomorrow, okay, you guys can have a good weekend. But I mean, look for the announcement tomorrow. Do not wait until after tomorrow to do the work that I've put in the announcement, because there are due dates and due times. Okay? So don't wait until Monday thinking you're going to turn it in, because you won't get full credit for it. So that's all that I have for today. We did limit controls and we talked about this other stuff.
Cool. Sounds great.
All right.
You guys have a great rest of the day.